Good morning. This is a quick video on how to draw free body diagrams using a given situation. So let's talk about a car accelerating. So if you have a car accelerating, like a picture of that, quick picture would be like a car. I'll call it a pickup truck. Is accelerating along the road. Okay, it's kind of heading in that direction. There are a bunch of forces acting on this car. We know that there is a force of weight here going up. There is a normal force pushing up, and the force pushing to the right would be the force applied, assuming you're using the accelerator pedal. And in the back, something pushing against that would be the force of friction, which is right in between the wheels here in the road. So rather than drawing a picture of the car, what we do for a free body diagram is we just draw it as, I'll do it underneath. You draw it as a dot. Okay, the car is a dot. And all you're going to do is draw the forces acting on the object. So, for instance, this is the car. Okay, this is the force of weight. Okay, this is the normal force. Okay, and then we've got a force applied, and then the force of friction. Now this makes it easy because I can put some numbers there. So we know that the force of weight and the normal force, they both balance out. So we can actually get rid of those. That's not important in this whole situation. Okay, so even if this was like 20,000 newtons, this would have to be 20,000 newtons in order for this car to not accelerate up or down. We don't see cars careening through the center of the earth. So, and we don't see cars rising. Maybe in the future, but not now. So if we say we have an applied force and a force of friction, generally the applied force is going to be greater than the force of friction because you do see cars moving, accelerating forward. So let's say we just had some numbers here. Let's say an applied force of 1,000 newtons. Okay, we'll say that is the case there. Let's say the frictional force provides a force of 250 newtons, negative, going backwards. Then what we say is the sum of forces, all the forces acting on this object or this car, is going to be the addition of all these. So these two cancel. Those are no longer a part of the situation. The 1,000 going to the right is a positive number. The negative 250 obviously is going to the left is a negative number. So what we have here is a negative 250 newtons plus 1,000 newtons. So the net force in this situation is positive 750 newtons. Okay, and then later on we can go and figure out how to get the acceleration from that net force. Yeah, that'll be the next video.